Hello and good day. Today in Algebra, we're covering CO2, estimating the root of a non-perfect square. So this is an objective. We just learned earlier today how to find a square root, how to calculate a square root using a calculator. Because we're going to be estimating them, you will not be able to use a calculator on this portion of the test. Just know that up front. So when we talk about roots or radicals, what are we talking about? What is a root? How would you define it? Yeah.
A number that times by itself equals a different number.
Okay, good. Yeah. A root is a number that, when multiplied by itself, equals the given expression. Okay? A number that, when multiplied by itself, equals the given expression. Kind of the opposite of a root is the exponent, right? Something squared. So if I ask you for the root of 81, or the square root of 81, what is that? What number times itself equals the given expression 81? Yeah. 9. Okay? And the reason for that is because 9 squared equals 81. It works the other way too. Thus, why the R belongs in PERMDAS, right? Exponents, radicals, they're related, they're opposites. Okay? What's a perfect square versus a non-perfect square? Talked about these in CO1. Non-perfect squares we know are irrational numbers. Perfect squares are, like the root of 81, we would classify that as being rational. What's the difference between a perfect and non-perfect square? Yeah.
Non-perfect square, the whole number can be multiplied by itself equals the given expression.
Right. Meaning that the root of a non-perfect square is going to be irrational, right? So a perfect square has roots that are rational. A non-perfect square has roots that are irrational. Okay. I'm going to scroll down before we fill out this table here, so get those definitions written before I do. Good? Okay. Rationals have roots that are, perfect squares have roots that are rational. Non-perfect squares, roots that are irrational. Okay? Pen down, clear ink. I'm getting the hang of this. The order of operations here. Live teaching, man, that's comes with its risks. Okay, so let's fill out this table for the perfect squares and then their roots. Okay, so root 1 is a perfect square. We're going to skip that one. We're going to start with root 4. Okay, what is the root of 4? What's the equivalent rational number to that? Root 4 is 2. Root 9 equals 3. Root 16 equals 4. What's the next one? What's 5 squared?
25.
So root 25 is 5. How about 6 squared?
36.
Root 36. Okay. 7 squared?
49.
Root 49. 8 squared? Root 64. 9 squared?
81.
Root of 81. So this is a little timeout here. So we've got these numbers that are all perfect squares up above here. Any number, like if I asked you, is the root of 23 rational or irrational? Since 23 isn't up here, right? It's between 16 and 25. You would know it's a non-perfect square. Okay, that's kind of where we're headed with this. 10 squared is root 100. 11 squared is root of 121. 12 squared, 144. And this is where your multiplication table stopped in elementary school. That 12 times 12. 13 squared. Some of you probably drive this highway to get here in the morning. 169. 14 squared. So if you're unsure in your calculator, this is where you would use that x squared button, so you wouldn't press the second function first. You type 14, then hit that x squared button, get the little 2, power of 2, and enter. James?
196.
Yes, the root of 196. 15 squared. Peter?
225.
Root of 225. And finally, 16 squared. James?
256.
The root of 256. Right? It will greatly behoove you to memorize your perfect squares up through 16 squared or 256. Okay? It's going to make work coming ahead go a lot more quickly for you if you're not constantly using a calculator to calculate stuff. Okay? Okay. So what am I talking about here with estimating a non-perfect square? Let's practice a few. And let's do let's all pick a number 1 through 100 that's not a perfect square. Sure. What?
69.
Sure. Okay. So we look at 69 and we see that it's not listed in our perfect square row, right? We've got the root of 64, which is a little bit low. We have the root of 81, which is a little bit high. 69 is in between there. But we can use these perfect squares to help us estimate its value. So, root 64 is the next perfect square below root 69. And what's the value of root 64? This is why it's important to know these. Yeah, 8. The next highest perfect square is 81, which is a value of what? 9. So because the root of 69 is in between root 64 and root 81, we know its value has to be between 8 and 9. Right? Does that make sense? Because if its value was 8, then its root would be 64. If its value was 9, its root would be 81. But it's in between there. So we know it's going to fall somewhere in this range here. And now we look at, is 69 closer to 64 or closer to 81?
81. No, 64.
It's closer to 64. So if we think of like, in the middle here, here's 8.5. Which side of 8.5 is the root 69 going to be on? The 8 side or the 9 side, Peter?
The 8
The 8 side. And here's where the estimating comes into play here. It doesn't really matter. I mean, it matters how close you get, but not really. At this point, root of 69 being closer to root 64 or closer to 8, right? I would accept 8.2, 8.3, even 8.4. Okay, it's probably more than 8.2, 8.3 range, but at least you're on the right side of half. So there you go. You've just estimated your first non-perfect square. How's it feel? Amazing. I know, right? Give me another number. 1 through 256, not a perfect square. Yes.
174.
174. Oops, hold on. put that in the red spot. I want it to be in the green spot. What did you say? 174? Yeah, okay. 174. Not a perfect square. It's not on our list, but we can use our list to help us. What's the next smallest perfect square? So root 174.
169.
Okay, so root 169 is here. And what's the value of that, James?
16.
Nope,
13.
13. And the next greatest one from root 174?
225.
And the value of that?
15.
So this poses a problem here. Because our range of values that we said it could be is between 13 and 15. There can only be a one number difference between them if we've done this correctly. So 225 is not the next largest perfect square from 174. It's actually, do you know? 196. Which has a value of 14. Right? Now we know we're in business here. Okay, we got 13, 14. We know it's between these two values because root 174 is between 169 and 196. Okay, so again, now we look at which one is it closer to. If the middle of this thing is 13.5, which side of that is the root 174 going to be on? Is it closer to 169 or closer to 196? It's something we haven't heard from yet today, a new contributor. Yeah, Schleifer.
59.
It's closer to 169, which means it's going to be closer to 13 than it is to 14. Right? And again, here's where you can kind of get a little bit of wiggle room. I would accept 13.2, 13.3, even 13.1. In this case, 13.4 is a little bit, I mean, it's within the right side of half, but this is only 5 numbers away from 169 versus 22 numbers away from 196. So it is significantly closer to 13 than it is to 14. So 13.1 would be a better estimation in this case than 13.4. But again, we're estimating. Okay. Questions on any of this? Okay. I'll give you another couple seconds to get those notes down if you need them. Start looking at the 8 I have for you below. Are there any of them that you would like to talk about that for whatever reason give you the heebie-jeebies as far as, that one looks a little bit scary. While you do that, I'll clear this. I'll expertly scroll down like a boss. There we are. All right. What do we have? Miranda. The negative ones. Okay. The negative root of 215. Let's just take that one here. Negative root of 215. There is a difference between what we have written here, the negative root of 215, and the root of negative 215. There's a big difference between that negative sign being on the outside of the root versus the inside. This one we can do. And really all it's going to mean is that when you're done, you're going to make your answer negative. It's the same process as above, only when you're done, your answer is going to be negative. This one, if you were to type this in your calculator, it would give you an error message because you can't do that until you're in Algebra 2. It's not allowed. Okay? So there is a difference there. A negative sign inside the root is a problem until we get to Algebra 2, and then it becomes okay. But anyway, so we're going to start this the same way as we did. Here's our root 215. Okay? And I'm going to kind of just ignore the negative sign for now. Remember it's there, but I'm going to ignore it for now because it really doesn't come into play until the end. What's the next smallest and next largest perfect squares here? What do we got? Miranda. 196, which is 14, and 225, which is 15. We know we're in business because 14, 15, they're consecutive numbers there. Everything seems to be good. So the root of 215 is going to be somewhere in between here. Now we look at half. halfway is going to be 14.5. Which side of 14.5 will this one be on? The 14 side or the 15 side? Joe? The 15 side. Why? Because 215 is closer to 225. It's only 10 numbers away versus 19 from 196. Okay? So where is it exactly here? I don't know. It could be 14.6, 14.7, maybe even 14.8, 14.9. It's kind of getting a little bit outside of the range there, but again, it's an estimation. Now is when we bring the negative sign back and we say negative 14.6, negative 14.7, or negative 14.8. If you choose to ignore the negative sign, make sure you bring it back at the very end. Otherwise, you would just, keep it here throughout, right? And we get the same result anyway. Real world situation. I'm no doubt you'll find yourself in this exact situation in the coming years here. Through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot of land to be a square with an area of 200 square miles. The length and width of the plot have faded because the map is old. Right? Approximately how many miles long and wide is the plot of land? So you're looking at this old map. You got a square plot of land here. The area of the square is 200 square miles. I'm looking for the length and the width. And the fact that it's a square is helpful here. Okay? And that's all I'm going to say about that. We'll talk about it tomorrow. Question or answer? Yes.
How for the top 8 would you check your answer?
So in a calculator, it does say check your answer using a calculator. And because I don't just want you to use a calculator to find the answer, this work does need to be shown. Okay? You can't just write your final estimation here. I need to see the work. Show me the effort. Show me the struggle. Okay? But if you were to type in negative root 215, you would get an irrational number, but it would round to be one of those three things. And that's how you could check. If you plug this in there and you got, negative 12.2, then you did something wrong because that's too far off, right? So you can check your answer using a calculator. The way I showed you earlier, if you need a refresher, you need to press that second button first. And then you want to press the x squared key, not because you want to square it, because you want what's above it, that root symbol, right? And then you type in the number that you want. If you're taking the negative root of 215, then before any of this, you would push the negative button to put it outside of the root. Okay, because a negative inside the root, you can't do yet. Mathematically illegal. All right, this homework is due for tomorrow. If you run into issues tonight, please do just send me an email and I'll do my best to steer in the right direction. The video will be posted later today. That, folks, is How You Math.
Don't forget to like and subscribe.
It's been a long weekend. We'll try it again. That is How You Math.
Don't forget to like and subscribe.
Much, much better. Thank you.